All right. Hello, everybody. Welcome to the Denver Gophers meetup. I'm Warren, your host, and Stacy's also your host. She's here too. And today we welcome Drew Dennison, and he'll be giving us a talk about GoSec, DIY GoSec rather. And I I don't have any other announcements. I mean, I hope everyone's doing okay and doing well. And yeah, I'm very glad that y'all are here to join us, even though you probably had 100 Zoom meetings this past week. So, Drew Denson, please take it away.
Thanks so much, Warren, and thanks for hosting me. As Warren mentioned, the title of the talk is DIY GoSec, and so we'll be talking about a new open source tool called Semgrep, and we'll be using that to do a lot of the same analysis that GoSec has, so you can kind of understand more about the checks and how things work. If you have any questions, feel free to stop me at any time, put messages in the chat. And I'll take a couple breaks, maybe at natural pause times to answer those. I also have a link to slides here in PDF form, which I posted in the chat. Welcome to skip ahead if you'd like. Let's see. Awesome. So the summary of this talk is that it's really hard to write secure code, although I think Go does a nice job compared to something like C++. And we need better static analysis tools. So GoSec is a great example. I think Go actually leads the kind of peer languages and having really great static analysis tools. But there's also a lot of commercial static analysis tools that I think often have a reputation for being kind of noisy or slow. And so the other end of the spectrum is something like grep, but I think there's some shortcomings with trying to grep through code, which I'll talk about. And then we need something it's fast, flexible, code-aware, and open source. And so that's Semgrep, and it's an open source piece of software that we've worked on and I'm going to talk more about today. So there'll be three use cases for Semgrep. First, we're going to let's search through code and find security bugs or correctness bugs, performance bugs. We'll talk about how we can build guardrails to once we have best practices in our code base, how do we make sure that ourselves or other developers, stay on the paved path that is secure. And then finally, we'll talk about ways you can take an old code base and mitigate issues and help you upgrade. But before we dive into all that, let me introduce myself briefly. So I'm Drew. I'm one of the co-founders of R2C, which is a small static analysis startup in San Francisco. And our mission is to improve the security of software through static analysis tools and other security tools. And we try to open source things where we can. My background is in computer science and development, but I've done some security work at a prior company and did a lot of incident response work. So my Zoom background shows a very different San Francisco than what was at least a couple weeks ago. And so just took a photo I found online. I'm actually in Chicago right now, but I'm based out of San Francisco. So the summary of the talk, I'll give a little bit of background about Semgrep. We'll talk about grep and other approaches, some of the theory, and then as quickly as we can, we'll dive into actually using the tool, and you're welcome to follow along if you'd like. And then finally, we'll talk about how you can integrate it into your build pipelines, and we'll talk about the community rule registry. So if you want to get Semgrep and get started, you can go to github.com. In our org, there's a Semgrep repo. It's got a nice README. Follow along with the installation instructions. The summary is you just brew install Semgrep or pip install Semgrep, but that's the open source Git repo. And Semgrep has a history. It goes beyond our company. And so Semgrep was originally written at Facebook in 2009, and that team wrote about 1,000 different rules for Objective-C, C++, and PHP, and eventually Hack. And the original author was the first program analysis hire at Facebook. And so he has a deep expertise in languages and program analysis. He got his PhD in this in France, and then he joined our company last year. The languages that Semgrep supports, so we have good support for Go, Java, JavaScript, JSON, Python, pretty much all the popular languages, and we've been adding a new language pretty much every month. in beta. And so this month we're working on TypeScript, and I'll talk about that more. Semgrep is LGPL licensed, so you're welcome to fork it, use it, contribute. We'd love contributions from the community. And yeah, so let's talk about some different approaches. So if you're searching through code, probably the first thing you're going to do is use grep. But if you're going to try to use grep for everything, and using regular expressions are great, but there's often, it just leads to more problems. And kind of why is that? Well, because even though we type software as strings into a text editor, whether that's Vim or VS Code, to the computer, if you ever think about what the Go compiler is doing, the first thing it's going to do is parse the language into a tree, and then every single part of the language has semantic meaning. And so you have function declarations, brackets, parentheses, and if we're just going to search through code using grep, we're going to lose all this information. And so it'd be much nicer if we could actually operate at the same level that the compiler is using as this data structure. So of course, Semgrep's not the first thing to ever want to do tree matching. This is how GoSec works using the Go AST module. And many languages have things, there's GoLint, Bandit, DLint, ESLint, Flake8. If you've ever used linter, under the hood, it's been doing this, whether you think about it or not. But one challenge is if you want to write your own linting rules, it's often a fair amount of work. So just for fun, I went and pulled up the GoSec rule to look for old calls to the crypto package. And it's like 95 lines of code. You have to walk this tree, look for things. You have to think about it almost as like a programming language expert. And you have to understand the API for GoAST. And that's just a lot of work if you don't think about this every day, all day. There might be some commercial static analysis tools, but it's kind of the outside of the scope of this talk. Regex, all the way into like whole program analysis, almost like a compiler. That's kind of the spectrum. And in the middle is this space called like AST or tree-based linting tools. And Instagram has a nice blog post about how they've written a variety of different tools on Instagram to help them evolve their code base. And Semgrep fits kind of in the middle, just to give you some context of what it's trying to do. So I'm trying to be easy and fast, but have more complexity and be able to do more powerful analysis by operating at a different level of abstraction. So I like to think about Semgrep is that it lets you reason about your analysis the same way you think about your code. One of my colleagues wrote a blog post about this and why they've switched to using all of their static analysis using Semgrep, because as you'll see through some examples, the analysis will look and feel a lot like the code that we're writing, and we can use the same skills we do whenever we're debugging or writing a program. So enough about background and theory. Maybe it'll be clear if I just jump in and show you some demos. And so if you'd like to follow along, you can. There's going to be sort of 3 different categories of demos. First, we'll talk about the tool and some of the language, and then we'll jump into some more advanced features. So the first thing we want to look for, I'm coming at this from a security function, but you could think about this or any deprecated API or something that you're like, I never want someone using this Go library or this function in my code base. Let's see how we would match that. So in this case, we're going to look for calls to RC4, where there's this new cipher. And I happen to know that RC4 is not a recommended cipher. We should use something stronger like AES. And I'm going to show you what we have is a live editor here. And so if you've ever used a tool like Regex 101 or another tool like that, this is just an online version, so you don't have to install the tool or run it from your command line. You can of course do that, patterns work, everything works offline, but we also have a debugging editor here. So real quick overview, I'm gonna paste in my pattern, and then I have some test code here that I'm trying to find. And then finally, matches will appear on the right. So it's just really easy to see more from a presentation perspective if I do this all online. So the first thing I have is just a very simple function. It's importing thumped and crypto_rc4, and it's doing some basic cipher operations. And of course, this is not very secure code, but I will show you that I can look for functions that I want to find. So to do this in Semgrep, I'm just going to copy and paste the function I'm trying to find. And then I'm just going to replace the argument with 3 dots, which is the ellipsis operator. And this just tells me, like, I don't care if there's, 1 call to it, 10 calls to the function, 2 arguments, 5 arguments. Like, we just want to find kind of anything, almost like what you'd write if you were explaining this on a whiteboard. So if I run that, you can see now it matches the 4 cases we care about. It correctly handles different arguments. It handles white spacing correctly. But you'll notice it doesn't match on commented out code or just a string with those same variables. So if I was trying to write a grep pattern for this, I might do rc4.newCipher, open parenthesis, and I would have a couple false positives where it's like, yeah, those are just comments, or someone's talking about it. And so this just shows how Semgrep is operating at the code level where the compiler knows, okay, this is actually a function call versus a string or a comment. Let's move on to another example. So for those who've done more advanced Go writing programming, you might have run across the unsafe package. And what that lets you do, for those who aren't familiar with it, it lets you escape a lot of Go's memory safety things. And so if you need to get a pointer, you can use the unsafe package. Now, of course, there's a reason it's considered unsafe. You might want to audit this. There might be some security issues like buffer overflows or things like that. But also there can be memory leaks. And so, typically just looking for calls to unsafe packages would be a good place to start searching through my code base. And so what I'm going to do here is I'm going to look for any function call with unsafe as the module. And then I'm going to go through and do a variable for function. So variables in Semgrep are just $, and then capital letters. And then I'll use the same ... ellipsis operator to find any function calls the unsafe package. And so if I run that, if I type that correctly, yep, it now finds the 3 places where we called unsafe pointer, unsafe size of, and that's just a really quick way for me to just use this as a Semgrep pattern and find any function in the unsafe module. Next, what we're going to do is we're going to talk about how we can actually compose patterns. And so I'm going to jump into a little bit more of an advanced feature here. So Semgrep can be powered by a single pattern, but can also use YAML files, and you can put in a lot more information. So in this case, I have a pattern that's almost all filled out, got a nice ID, it has a nice message, there's some metadata with some security, like OWASP things, and pages you can go read more about it. And I just pulled this directly from the GoSec check looking for TLS configs. And so here we have, there's 2 ways you can set up TLS that's not secure. And let me see if I can show you a little bit of those. So here we've imported the crypto TLS module. And then in this case that we've already found, we're using TLS version, an old version, SSL 3.0. And that is known to be insecure if you read any of the documentation by Mozilla or some of the other internet authorities, and they recommend you use, I think, TLS 1.1 or greater. The other way we have is when we're actually going to go through and skip the verification. And so even in the case where we have TLS 1.0, this is a good version. We've turned off that the server certificate is not trusted. And so we're going to skip that verification. And this lets an attacker man in the middle of the connection. And so we just want to basically do a little bit of like Boolean logic here. So the first thing we're going to do is we're going to find any call to TLS config with a min version parameter set to a specific version. Or I'm going to copy this in. And we don't care about the min version in this case because we've already handled that case. What we care about is calls to insecure skip verify, and that's set to true. So now I have a rule, a check, just like in GoSec, that will catch both insecure versions of the cipher or if someone's explicitly disabled the server verification. And if you have any questions, I'm happy to talk about that more. But now you can see we've correctly matched both cases. And so this check is basically good to go now. And I could actually go through here and click follow the instructions to run this locally. If I wanted to on my own code base, I just pip install Semgrep, and then I could run Semgrep with this shareable URL. So I've created a shareable URL, and I can run this snippet on my code base. And if I have a few thousand line project and I just want to make sure that like I never make this mistake or no one else does on my project, you know, I can now alert myself. We'll talk about that more later. I've skipped a couple slides just in the interest of time, but if you want to download the slides and go through them, they have all the full examples. You can see some of the documentation. It's all on our website of like the different operators in that YAML syntax. But let's keep moving. And so if we think about more of a medium complexity demo, the next thing we want to do is look for anti-patterns. And so what I have here is an interesting blog post I was reading about hidden Go routines, where it's an anti-pattern if you have a function that only directly calls a coroutine and doesn't do any additional work. And the reason this is because you would expect a regular function to be synchronous, but if it just immediately invokes you know, the coroutine, then you're going to have an asynchronous function, and so that's kind of confusing. And a better solution is to just keep the function simple and then just call it outside that function. And so this is an example of how I could look for calls to that. And so here I have two patterns, and I'll just kind of walk through these each line by line. It's just a function, any function name with any arguments. And then if there's just go function, again, with any arguments or you know, any body, then the ellipsis operator, the 3 dots, will abstract away that, whether the function's 2 lines or 500 lines. It's just looking for this structure in the tree. And what we don't want to say is we want to say the code looks like this, but we say it's not this case where we have additional work being done, because that's fine, you know. And so this is the kind of bad function we're going to try to find with hidden Go routine. As you can see, it's immediately invoked asynchronous function, just printing out hello world. And that's an anti-pattern. And then here we have a case where it's like printing something else out and doing other work, and that would be normal, just like the main function would be. And so a couple different cases. And so now I've just written the rule. I can reason about it. I can think about it. Fairly similar to the code. I don't have to understand how the trees work underneath the hood. I can just use this pattern. And now I've sort of codified the knowledge that I would have as like a senior engineer looking over code saying this is a bad practice and maybe we should do something different, and save that as a function. The next thing, also kind of thinking about this from a security perspective, but you could imagine this as a logic bug or correctness thing or a race condition, and we've written a lot of rules in that same scenario. But in this case, I've been like reading through the source code, and I found this comment where someone's like, hey, this fictional trading application, you have to take every single like financial transaction and you need to verify it before you save it to the database by calling make transaction. And so that's like hidden knowledge that, you know, maybe someone more experienced in the project knows, or it's in a comment, but you know, really who reads comments? And it would be nice if we could write a check like using a tool similar to like GoSec or maybe GoLint, but let's see how we would write that with Semgrep. So again, let me see if I can, sorry, I'm zoomed in here a little bit, so it's a little bit hard to see the test code, but it's a very simple program. It has a main function, hello world. And then I just have a couple test cases, just like I would with a regex, where I'm going to say match this line, but don't match this line. So in this case, like it's correct, someone calls verify and then they make it. Here they forget to verify it, just saving it directly to the database. You know, that would be a problem. Maybe the order of operations is wrong. Maybe there's some other statements around it. And you can think about how you try to like match this with grep. Maybe you try to grep plus minus a couple lines. Maybe you try to write some Go code to look for it. I don't know exactly how you'd do it, but it would be a little bit complicated. And here, just to show some of the complexity, even in this case that maybe looks fine, if you were just going to grep like one line above it, you'd see that verify is called right before make, but it's a different transaction. You know, it's a new object being created here. And so I've written a little bit of Semgrep code using just the two things we've talked about earlier with $method for any method, and then the ellipsis operator to abstract away statements or expressions or function calls. But there's one constraint that I forgot to express, which is that if I'm going to verify the transaction, I should really give it a variable, and then we'll let Semgrep do the logic to say, okay, if I call verify and then I make it, it has to be the same transaction. And so we'll enforce that by using a variable, in this case, $T. And then if I run it, hopefully it will catch the case where we wanted to find it, where someone created a different transaction and then they made it. So you can see all the different calls that happened. So I know a lot of that was fairly fast. Maybe we can take a quick second here. If anyone has any questions, feel free to let me know. People can turn their mics on, or if you have questions, you want to save them for the end, that's fine too.
I had a question. So in that example that you just showed, you were using the simple view. If you click the advanced view, do you get to see how, like, I'm assuming that's like how the rules are written, right?
Yes, absolutely. So the simple view is pretty straightforward. You just like match code, literally copy and paste it, change some things out, and then you can choose like it's this or it's inside of this or it's not. But yeah, you can always pop over to the advanced YAML view and you'll see it does a little bit of OR logic, and then the pattern's the same. And in this case, I actually wrote a really nice message that said, okay, like, and you can reuse those same variables in your message, so like in some method. And so when I run it, the matches will come out like in no verify and late verify. And if you run this on the command line, there's also like a nice JSON output where you can get all the variables. And so you can do further processing later. Does that answer your question?
Yep.
Perfect. All right, so let's talk about a couple more example that I want to talk about. And so if you've ever used Gorilla, which I know is one of the more popular frameworks for basic web APIs, I'm going to use Semgrep here to help me extract the different parts of the route handlers, right? So standard Gorilla, you have an initialize route function where you go through and add in all your handler functions. And so in this case, I have like a very simple CRUD app that has like products where you can create, update, delete, etc. And what I'm going to do is just use the same things we've learned about earlier with Semgrep, where we're just going to say we don't really know the name of the app, so that's a variable, router, handle function, and then we know the route and the handler, and then also we're going to grab the HTTP verb. And so I'm just going to do it that way. And then if I run it, you can see it matches, and we're using that same like message interpolation here to show you the variables get pulled out as different parts of the program, and I can do some further post-processing. So this is obviously not like a GoSec rule where I'm trying to say like, oh, this version of TLS is bad, but I'm going to start combining it in a way that I think is interesting from a security perspective. And so what I did was I just extracted that out, dumped it to JSON, and then imported it into D3. And this is, the details aren't super important here, but just I pulled this out of a consultant engagement we did. And we had the ability to just like kind of visually show the hierarchy of every web app route. And then we color coded things. I think green meant it had like authentication and authorization, like you had to be an admin or something to hit those routes. And then red was like missing, kind of open to the world. And yellow was like maybe signed in, but regular users could see it. So it's just an interesting way to sort of combine Semgrep to pluck out the parts of the code that you cared about. And then you can do a visualization as a second pass and like present this to easy to see like misconfigured routes or maybe missing auth decorator requirements. The next thing I want to talk about is autofix. So we talked about the example where someone's using like TLS version 3.0 or SSL 3.0. And that's obviously a problem. We'd like to encourage people to use a better version. And so one nice thing you can do using the advanced version here, took the same rule that we wrote, but we actually let you do a regex. And so you can fix like this version of the code should actually be version TLS 1.3, which is the latest version. And so when I run over the code, I find the match just like I did earlier. But now I get this little autofix button, and I can just click autofix apply, and it will go through and update the code to TLS 1.3. And of course, this works on the command line. There's like a -a autofix flag that you can apply, and it will just update the code in place. Obviously, this is useful in the case where you're just like changing out a parameter. If you're doing more complicated things, you can do autofix actually using the different parts of the program. And not everything can be fully autofixed. Sometimes there's additional arguments that you might need to pass in that you don't know about, but at least now it gives you a starting place to think about how you can kind of mutate the code and fix the code. The next thing you can do, if you read the documentation, is we actually have some built-in Python scripting languages. So you can run and then take the variable and you can apply a regex to the variable. So you can say like the variable has to be a integer, or has to match this pattern, like 10.0.0 is like internal IP address or something. But if that's not enough, you can also pop into the case where you have some Python code, and you can do anything you want with it. Of course, that's dangerous, so you have to add a like dangerously allow arbitrary code execution to Semgrep, so it'll actually execute the Python code. But you can do things like comparing integers, doing the rest of that. And so I'll show you an example of that here, where I have some RSA keys, and I've decided that we don't want people using 1024-bit RSA keys. They have to be at least 2048, which I believe is the latest NIST standard. And so what we have here is a little bit of code. So we're looking for, let me just show you the Semgrep part of it. So we're looking for RSA.generate key with any number of arguments, and then we're grabbing that last argument, which is the number of bits for the key, putting that in a variable, and then I'm just doing a little bit of Python here to just grab it, convert it to an integer, and check to see if it's less than 2048. But you could do multi-line Python, import other functions, use random string entropy libraries to look for hard-coded tokens, things like that. We use that as a nice kind of escape hatch. And then over time, we'll try to figure out, okay, everyone seems to be doing this. We need to build something new as a special syntax inside the YAML file. Cool, and then I have some more slides here that I won't go through, but just kind of recapping what we talked about. So, what does it look like to write a pattern? Well, there's really only two things you need to know. So one is patterns look like code, and then you just replace any part of the program with 3 dots just to get rid of basically match zero or more arguments, lines of code, expressions, and also you can use variables, and that also will match different sections of the code. But next we want to talk about how we can actually start to guard our code base, because I think if we're just kind of looking for bugs in our code, we're always playing this game of whack-a-mole, looking for bugs and, oh, is it really a bug? Maybe it's a false positive. It's okay because there's an if check over here. And what we really want to do, if we look at the way companies like Google, Facebook, Amazon, the best of the companies, they're all starting to write more secure wrapper libraries, and they're saying that, hey, it's 2020, we just should never use store copy, right? So even Google created Go because they just didn't want to have any of those whole class of vulnerabilities or performance issues with like direct memory access. And so Go, of course, has memory safety. And I think in general, on the security side, the more you can use frameworks that are known to be vetted, and there's a couple sharp edges, and then you just make sure yourself or somebody else on your team doesn't use one of those kind of dangerous or sharp edges unless people really look at the code and really think about it. You can prevent just kind of casual, hey, I didn't even realize I just copied some code off Stack Overflow. And so what we of course want to do is get this into our continuous integration setup. So you might have seen me earlier when I clicked like the little deploy. You can of course do this locally by just copying and pasting in your file into like the YAML file and just run this all yourself. We have a Docker container, we have JSON output, but also the web app lets you just say, hey, put this in your GitHub file as a workflow thing, and that will use the new GitHub Actions thing to go through and every commit and check that out. GitLab integration, Circle CI, Travis, etc. So that's how we use it to scan all of our code. and what it looks like when it actually runs in like the GitHub action context here. So this is like a real vulnerability we found in our own code base. As it ran, this is in some Python file, but we found that like request data was being called in like open and it wasn't being sanitized. And so that's like classic injection vulnerability with path traversal. And so these are the kind of alerts now that you can say, oh, wait a minute, whoops, that was a mistake, or that's a false positive, it's totally okay, but let's like update our comment and explain kind of what's going on here. So we started writing a bunch of rules, and we were just managing these all with local files. We had a Git repo full of rules, and other friends wanted to contribute that. And so that was, we started thinking about what would it look like to build this kind of community registry, similar to like NPM or Go modules, where anyone could contribute their rules. And what we found is we have a couple hundred rules. So I think we've written over 700 rules, and then the community's written about 100 rules. And actually one of the more popular like Node.js scan, which is really popular for scanning for JavaScript vulnerabilities. They used to use a bunch of regexes looking for security vulnerabilities, but they've now transitioned to Semgrep, which was really cool. Ajin did a lot of great work there. And then we went through and just looked at all the GoSec rules, and we wanted to just make sure Semgrep could find everything. So we have ported all the GoSec rules and the findsec bugs for Java have been ported over. One cool thing is you actually don't have to have compilable code. And so we have been working on a VS Code plugin. So actually, as you're typing, you can now be running the Semgrep checks in the background, and it doesn't have to be working code. And we've gotten a bunch of other great ideas from people like on the core team and different web frameworks, and hackers from HackerOne have contributed rules. So it's pretty cool to see how the community has grown. And what I love about it is you don't have to be an expert in every little bit, but you can just say, hey, let's import a whole section of rules, and you can learn from everyone's knowledge, and people can share their learnings. And actually a really cool organic example of this was Damian Gursky, who wrote Go Perfbook. He's written like 25 Semgrep patterns now. Most of it's all around things like math bits and different expressions, and there's performance ways you can use Hint to the Go compiler to optimize that code. And so he's written a bunch of rules, and I can show you some of those rules. If we go to the editor, there's like the Explore tab, and I can show like all rules. This will load in just a second, but things are broken down by like language, severity, different categories, and so you can just sort of think about what rules you want and import them. If we just look at like Damian's rules, let's see, here's some of the different Go rules he wrote, like looking for these various anti-patterns. And so it's always kind of fun for me to just read through all these rules and say, oh, I didn't know that. But now he's, it's kind of codified. And so I can open that up. I can run it. If I want to locally, just copy this, run it on the command line, and see if I find that in any of my code, or I can add it to my own like policy if I want to scan this continuously. So to use the community rules, you can use the live editor site, which has a registry thing. And that's actually just backed by this Git repo here. So if you don't want to do that, you can also just clone this and then pass in like semgrep config and just pass in either a URL or a Git repo that's on your disk, folder of rules, and it will just use those to scan over the code. And we have a couple different ones. So I mentioned like have a pack that we've collected a bunch of different rules called the GoSec pack. And so you can run this command here if you'd like to, just to get how we've imported not all of the GoSec rules, but most of them. And tried to copy messages and link back to the original GoSec documentation, but that was pretty cool. And what we have coming soon, so we have TypeScript, that's in development. Last I looked, we were like at 92% parse rate. So we're doing a little bit of work there just to improve some of the TypeScript stuff. We fully support JavaScript, but a lot of times you can make more precise rules if you know the type of the variable. And we're also working on using LSP with like a Go lang server backend. For those who have worked on something like that, that can let us get even more type hints about the pattern. So you can start to like write a rule and say only this specific type, or like look for rules like if it's an error, but it's not actually an error type. So that's some of the roadmap that's coming soon. We're writing more rules. We're also writing like cheat sheets. So if you're like, how do I just make sure I never have SQL injection or cross-site scripting in this Go framework. More cheat sheets are coming soon. And then, of course, all the rules. I also mentioned we have a VS Code extension, and that's in alpha development, but starting to get some beta users like testing it out, and you get like nice little red squiggly lines whenever you violate one of the rules. And then finally, for folks who've done more complex static analysis, kind of even going beyond what like GoSec has, there's full taint analysis. So maybe you want to write a rule that just says anytime user data can get into this function, where like maybe that's coming from an argument or it's coming from like a website or with a network. So you can start to write more complex rules and fewer lines of code. Let's see, I think I saw there might be a question. 3 different chat messages. Great, awesome. Yeah, so that's kind of a fast tour of Semgrep. If you'd like to try it out, you can go brew or pip, whatever you prefer, and just do install Semgrep. That will bring in the latest version. If you're not ready to install something, definitely check out semgrep.live. That's the live editor. And the slides have links to both like the try it and then also the solution if you get stuck. And if you want to just like run kind of a configured set of rules, you can do config equals R2C, and that will run not all the rules, but maybe some of the more well-tested rules on your own code. Also, if you have any feedback on this talk or you want to learn more or join our mailing list, you can go to r2c.dev/survey. That's completely optional, but I would love any feedback you have on the talk or the tool. With that, I'd like to open it up for questions.
All right. Does anybody have any questions? No? Wow. Well, I had a question. So let's just say I'm in a project, and I guess you kind of answered it partially because you said you can run semgrep and just pass as a config, you can pass it a URL. But if I had a file that had a bunch of rules, it kind of looks like, okay, I'm looking like a if it gets to be quite large,
sure.
It'll be kind of daunting to sort of visually parse that. Is there a way I can just copy all those rules and put it like in one of your visual editors, or just sort of have a visual way to like say parse it? Because one thing I did like was in the simple view versus the advanced view, it was like very clear, like this pattern, not this pattern. So I was wondering if y'all had a way where I can just copy paste these instead of rules one by one. I can just take the entire file and be like, yeah, I just want to look at all my rules and sort of go through them and scroll through them visually.
Yeah, totally. And actually, that's a great feature request. I feel like we should support multiple rules being pasted in and then like kind of visualize that. But maybe more specifically to your point, so you can certainly pass in a single rule and then in the advanced view and like have it pop into the single view. You don't also have to put everything in a giant file, so like that certainly works, but you can also put it in a folder of just different YAML files. So like I could pull up Damien's rules, but he just has a Git repo with like 30 files, and each one's sort of broken down by, okay, this one's like performance optimizations with math, bit shifting, things like that. So that's one option. And then the other thing you can do is if you write the rule in the like kind of the live editor, you can also just save it to, we have this concept of like a pack or a collection of rules, and you can just be like, add it to my pack, and then eventually you can just be like, run everything in my pack. And so that's not super complicated. You can also throw it as a gist. A lot of people I've seen just like paste their rules into a single gist and then set up their CI to run using that gist. So it doesn't have to be on our site or anything.
I see Rachel says she's trying to add it to her CI.
Nice, Rachel. Yeah,
Awesome.
happy to, feel free to ping me or tweet at me or email me or something if you want any help. We also have a community Slack. You can go to like r2c.dev/Slack. If you just want to chat about rules or be like, hey, I can't get this thing to match. I'm like, what am I doing wrong? There's a bunch of people, who work with me, but also just in the community who've written a bunch of rules. And yeah, I hope this is an interesting tool. I think the part that's been most exciting for me is just seeing people write new analysis in a few seconds. So like we had a case in our Python code base, like for this live editor we were working on, and it was like, somebody left in a debugger and they're like, yeah, well, we should just write a rule so we never leave our debugger in. So, 2 seconds later, we wrote the rule, added it to CI, and now like going forward, we just know we'll never make that mistake again, which I think is really powerful.
Yeah, I can definitely see a rule for like checking to see if you have spew.dump in our
Mm-hmm.
Go code. It's a library we use to like just dump all our objects when
Yep.
debugging.
Yeah, and
Um,
actually another thing I've seen people do is they're like, there's only one way to log things because we might make sure like privacy wise we're not logging passwords or PII or healthcare data or whatever. And so it's like no one should be calling like print, and they should be calling this like import safe logger.log kind of thing. So yeah, definitely things like that. I'd say like kind of on that guard side of things.
Another idea for folks in the call who might be contributing to open source code might be very, if you're wondering, hey, how do I contribute to this project? I really want to contribute. Just probably run Semgrep on on the code base and see if anything pops up, and then be like, okay, I'll fix some things here and there. Yeah, that
Yeah,
that might be
or
a good way.
if you run it on a code base and it's taking forever, or it's like some weird parse error or something, definitely file an issue because we have a CI system. We try to run it on a couple hundred projects just to make sure it's like no regressions or any parse problems. So definitely let us know. It's a great idea.
Yeah, Rachel, you can build a CI where it just runs it on the open source projects, and then if it finds any issues, it just creates a GitHub issue automatically.
That sounds cruel. But it does seem like it could be something that if you're trying to like increase diversity or get newer engineers involved in projects, you could like post those things to uh, lists where folks like that hang out.
Yeah, and actually we had a really cool project, I think with OpenEdX, where they were like, we have to make sure that we like call accessibility functions or things that will do different translations on the thing. So they had a specific function they wanted to make sure every function that did the rendering was wrapped in to do that, like make the code accessible for however they were doing the multi-language stuff. So that was a cool rule that like I never would have even thought about, but they wrote that and like someone posted as part of their CI just to make sure that like every time someone contributes to this open source project, people are at least thinking about, hey, is this going to be easy to be accessible or translated. Great. Well, I'm happy to hang out and keep chatting, but that's pretty much all the content I had.
Cool. All right. Yeah, what I'll do is I'll just stop recording since that's the end of the talk. Thank you very much, Drew, for this awesome talk about this tool. I'm glad that it's open source and that we get to contribute and use it free of charge. So thank you. And I'll stop the recording, but if y'all want to still hang out, we can still hang out and chat and stuff. Here we go. 1, 2, 3.